Hello, everybody. Welcome to another GeoBoost video. So we talk about the specialization in shallow geothermal energy. And we are in the Module 1, Introduction to Geothermal Fundamentals. And I will present today the Submodule 1.4, Ground Source Heat Pump Systems. So my name is Kai Zosida. I'm from the Technical University of Munich, and I will tell you a little bit about ground source heat pumps today. First of all, you see here a heat pump in general. So what we have, of course, we have a heat source and we have a heat pump, and then we have the heat distribution system here. And we are talking today now about the heat source. So which heat source can we use actually for the shallow geothermal systems? So you see here a picture of different sources. We always have closed loop systems and open loop systems. We see here some closed loop systems like a trench collector, horizontal collectors or very shallow pipes digged in the underground just a few meters under the surface. We have vertical pipes here. So there's a borehole heat exchanger. We can have for larger buildings also borehole heat exchange fields, so connected borehole heat exchangers. And we can also use some geostructures like here pile heat exchangers or also tunnel systems. And we can also have some open loop systems like here groundwater heat pumps, for example, or springs. Sorry, all that actually needs. So to plan such systems, you need also some parameters. So which are some parameters I show you here for implementation and planning such ground source heat pumps. So of course we need the ground temperature, for example, to see okay how much heat is in the underground. What is the difference from this temperature to the temperature we need in the household, for example? Then we need one of the most key parameters, the thermal conductivity. So the property of a material to conduct heat, which is a very, very important parameter for us, and also is very essential for the efficiency of such a geothermal heat pump. Also, not only what the heat can conduct it, also how much heat can be stored in the underground. This is here the specific or volumetric heat capacity, what we need and what we have to know and what we have to measure. And these are most parameters what we need for so-called closed loop systems. If we look at the open loop systems, we need different parameters, like we have to know what is the condition, the groundwater condition in the underground. So we have to know where are the groundwater levels, how much groundwater do we have in the underground. So what is the aquifer thickness, also what is the aquifer temperature here. Also to say what is the difference between the temperature in of the groundwater and the temperature what we need in the household. Also some parameters like hydraulic gradient plays a role. This also control a little bit how fast the groundwater flow in the underground and how a thermal plume, so how the heat actually transported in the underground. So these are some parameters, key parameters. We will talk about them later on a little bit more in detail, but just to give you a rough overview. We have also some design operational criteria. So what is the heat demand of a house? This is also what you need for the planning, and also what is the peak power. So these parameters depending also on the building characteristics. Is it insulated or not? And must be assessed before we start to plan a geothermal heat pump. And also for economic operational criteria, of course, the cost plays a role to see if our geothermal heat pump at the end is economic efficient. This gives you a rough overview about the geothermal heat pumps or ground source heat pumps. And in the next videos, I'll go in detail of the closed loops, the most common closed loop systems and the most common open loop systems. See you there.